Welcome back to Infinity Beyond. We've soared past planets, stars, galaxies, and even black holes. But tonight, we look ahead, not just into space, but into time itself. What happens when the stars go out? What becomes of a universe that keeps expanding? This is the story of the end of everything. Let's begin where we are now. In a universe still full of light, stars shine, galaxies dance. Life exists, but it's only temporary. Even now, the universe is changing, expanding, cooling, aging. Our sun, like all stars, is not eternal. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, swallowing Mercury and Venus, and possibly Earth. After that, it will shed its outer layers and become a faint, cooling white dwarf. Other stars will follow similar fates. The massive ones will explode as supernovae, leaving behind neutron stars or black holes. Eventually, the universe will enter a new era, the degenerate era. This is a time where no new stars are born. The galaxies dim. Only the embers of the cosmos remain. White dwarfs, neutron stars, black holes. Over trillions of years, even white dwarfs will cool into black dwarfs, invisible corpses of once bright suns. The skies will go dark. But it doesn't end there. These remnants will continue to interact, slowly losing energy through gravitational radiation. Planets will drift away. Stellar remnants may collide, creating momentary flashes. But overall, the universe becomes quiet. In 40 years, a number so vast it's nearly impossible to imagine, black holes will dominate. They'll be the last energetic objects in the universe. But even they are not forever. According to Stephen Hawking, black holes slowly emit Hawking radiation and lose mass. Over unimaginable timescales, they shrink and eventually evaporate completely. One by one, the black holes will vanish. When the final one disappears, the universe will enter the dark era. No stars, no light, no structure. Just an ever-expanding fog of cold particles, protons, electrons, and photons drifting endlessly. The cosmos, once so alive with energy, will become a frozen sea of nothingness. This is called the heat death of the universe. In thermodynamics, heat death refers to a state of maximum entropy, when all usable energy has been evenly distributed. There's no difference in temperature, no gradients to do work. The universe becomes thermally balanced and utterly lifeless. Time still moves forward, but nothing changes, nothing evolves. It is the ultimate stillness, but heat death is only one possible ending. Another theory is the Big Crunch. If the universe's expansion were to reverse, due to gravity overcoming dark energy, all matter and energy could collapse back into a single point. The universe would shrink, heat up, and potentially lead to a new Big Bang. A cyclical cosmos, forever rebirthing itself. But current data suggests expansion is not slowing, it's accelerating. That leads to another possibility, the Big Rip. In this scenario, dark energy becomes stronger over time. Galaxies are pulled apart, then stars, planets, even atoms. Eventually, space-time itself is torn asunder. Everything is ripped apart, including the fabric of reality. This cosmic ending would be violent, fast, and final. But it hinges on the nature of dark energy, which remains mysterious. Is it constant? Growing? A temporary phase? We simply don't know. And then there's the most speculative idea of all, that our universe is not the only one. Some physicists propose that the Big Bang may have been a quantum event, a fluctuation in a larger multiverse. If so, our universe might be one bubble among many, each with its own laws of physics, its own beginnings and ends. In this multiverse, the end of our cosmos might not be the end of everything. Other universes could be forming right now, blooming like flowers across a cosmic landscape. New Big Bangs, new physics, new possibilities. And here's something even stranger. Even nothing may not be empty. Quantum mechanics tells us that empty space seethes with virtual particles. Particles that blink into existence and annihilate in a flash. If space can never be truly empty, then maybe the seeds of creation are always present, waiting for a spark. Some theories even suggest that from the vacuum of a dead universe, a new universe could be born, a rebirth from the ashes of heat death. So, is there truly an end? Or is the universe a cycle of beginnings, expanding, cooling, collapsing, rebirthing, forever? We don't know the answer, but the question matters. It connects us to something bigger than ourselves. It reminds us that we are part of a cosmic story, with a past, a present, and a destiny. As segment 7 comes to a close, we rest at the edge of eternity. The stars fade, the galaxies dim, and yet we are still here, dreaming, asking, wondering. This is the gift of science, not certainty, but curiosity. Not answers, but exploration. This is infinity beyond, and though the universe may one day fall silent, our fascination will echo forever.